June 2016, question number 6 on paper 1. A comet passes close to the Earth. An astronomer observes the position of the comet and the Earth on the same day each week for several weeks. The diagram shows her observations for weeks 1 to 11. Complete the path of the comet between week 5 and 7. So it should continue like that. It's going to be a elliptical orbit. And then we're going to go to 2, mark an X on the diagram to show the position of the sun. So we can have it somewhere here because that comet is being pulled by the sun and it accelerates around it and out. So the comet was somewhere in there. Sorry, the sun would be somewhere there. Suggest why the astronomer did not observe the comet during week 6. Well, there's a big sun in the way, so the comet was behind the sun. Behind the sun. That would be a good one. You could also have something like comet was obscured by the sun, light from the comet could not reach the astronomer, sun was too bright, we should not look directly at the sun. And then we're going to move on to number 4. The observation showing the comet nearest to the Earth was made during, so let's have a look. When was the comet closest? So here it is, we got 3. This is when it goes over the orbit of the Earth. So it's probably going to be, this is probably our closest, so we're going to say week 9. Week 9 is closest, so we look at 7. We looked at 7. 7's definitely not closest. 8 is pretty close, but not as close as 9, and week 10 is right out. Explain how the diagram shows that the speed of the comet changes as it moves from position 1 to position 5. So here you can see that the distance between these 2 observations and these 2, but then these 2 and these 2. So actually, we have the same time between observations, but there's different distances. 3 after different distances. So because there's different distances, but there's the same amount of time, as the distances go up, we could just use speed equals distance over time in order to work out the different speeds. So you could have anything from same time, different observations, different distances between the observations, and using speed equals distance over time. Suggest why the speed of the comet changes. Well, it's becoming, where is it going towards? It's going towards the sun. So it should be, as it moves towards the sun, the pull of the sun is greater on the comet and accelerates it faster. You could have also had another argument, which would be the GPE going to KE. As the comet moves towards the sun, it loses its gravitational potential energy, and we know that there is a link between gravitational and kinetic. So as it loses GPE, it should be gaining kinetic energy. There's lots of reasons there why the speed of the comet would change. The Earth orbits the sun once in 365 days. The radius of the Earth's orbit is 150 million kilometers. Calculate the orbital speed of the Earth in kilometers per hour. Well, first of all, we've got this in days. So if they want it in hours, then we need to turn this into hours. So there is 24 hours in a day. And then the radius of the orbit. Now, this is a radius. If you want the orbital, then this is 150 million. So we need to turn that into a circumference. So what we're going to have to do is velocity equals, this is the circumference, and this is the time. So this is going to be 2 times pi times 150 million divided by 365 times 24, and that leaves our orbital speed to be that. I think what a lot of people do, if they get this wrong, they might remember that they have to put it into hours, but then they just divide this. The orbital is how fast it does this, not this. So you need a link between what do we use the radius for if we're going to work out the circumference? Well, circumference is 2 pi times r. So we can just use that to work out the total distance. Okay, that's question number 6.